What's up, you freaking geniuses? So in this video, I'm going to teach you how to find missing dimensions of similar solids when you're given the volume. Okay, so we're going to go over two examples. We're going to start with this prism example, and then we're going to do one with a cylinder. Okay, so for this problem right here, we're given two triangular prisms. This smaller one is prism A, this bigger one is prism B, and we're also given the volumes of both of these prisms. So this one is 12 centimeters cubed, and this bigger one is 40.5 centimeters cubed. Okay, we're also given this width right here that is 3 centimeters, and we're trying to solve or find this width of this smaller prism, which is just labeled as x, all right? So in order to set up this problem, you want to first compare the volumes. And the way that you do that is in a fraction. So you could say, for instance here, we could compare the volume of prism B to the volume of prism A, all right? It doesn't really matter which one you put on top and which one you put on the bottom, as long as you keep it consistent, right? That's the key. So we're gonna compare the volumes, and then you're gonna set it equal to k cubed, and k is a scale factor. Okay, so now that we have our formula set up, let's just plug in what we know. So first of all, the volume of prism B, what's given right here, right, as 40.5, and that's going to be over the volume of prism A, which is 12, and that's going to be equal to k cubed. Okay, now if we divide these, you're going to get that this is equal to 3.375, and again, that's equal to k cubed. All right, now in order to solve for k, the scale factor, we need to get rid of this exponent, this 3, and in order to do that, we have to take the cube root of both sides. Okay, so on this side, the cube root and the cubed exponent cancel out, so we're just left with what's inside, which is just this k, the scale factor, and that's going to be equal to the cube root of 3.375, which is equal to 1.5. Okay, great. So now that we know what our scale factor is, we're going to set this equal to another fraction, kind of similar to what we did over here. And this time, instead of plugging in the volumes of A and B, we're going to plug in similar dimensions. So here, the two similar dimensions that we can plug in would be the widths, right? So for instance, this width that we're looking for, which is labeled as x, and this width that is labeled as 3 centimeters. Okay, so those are the two dimensions that we want to plug in here. So which one goes on top and which one goes on the bottom? Well, it just depends on what you plugged in originally. So originally we plugged in B on top and A on the bottom. So we want to keep that consistent. We want to plug in B on top and A on the bottom. So B, prism B, would be 3 centimeters. So we're going to plug in a 3 on top, and A is this unknown side, which is labeled as X. Okay, great, and I'm gonna make this a little bit shorter just so it doesn't look so crazy. So now let's plug in to this formula, let's plug in what we know. So we know what our scale factor is between these two, right? It's 1.5, so let's plug in a 1.5 for k right here. And again, that's gonna be equal to 3 over x, all right? Now, in order to solve for x right here, we need to get it to the numerator first. So let's multiply both sides by x. Okay, on this side, the x on the bottom and the top cancel out, so we're left with 3 is equal to x times 1.5, or we could write that as 1.5x. Okay, and let's move this up here just so we have a little extra room to work. So now here, to solve for x, we just need to get rid of this 1.5, and we can do that by dividing both sides by 1.5, right? These cancel out. So we get that x is equal to 3 divided by 1.5, which is 2. And what are our units? Well, we're working in centimeters, right? So x is going to be equal to 2 centimeters. Boom. All right, here's the next example. So this time we're going to compare two cylinders, right? So we have cylinder A and cylinder B. This cylinder A is the smaller one, right? The height right here is given as 5 feet, and the volume is given as 7 pi feet cubed. And then for the bigger one, cylinder B, this height is unknown, but it does give us the volume, right? It says it's 56 pi feet cubed. Okay, so again, the first thing that we want to do here is just compare the volumes. And it doesn't matter which one you put on top or which one you put on the bottom. You just want to keep it consistent for that second step, right? So here, let's just write, let's just put the bigger one first. So let's say the volume of cylinder B, and we're going to compare that to the volume of cylinder A, and we're going to set that equal to K cubed, where K, again, is our scale factor. Okay, so let's plug in what we know. So we know the volume for B, right? That's equal to 56 pi, and we know the volume for A right here is 7 pi, and that's equal to K cubed. Now, if you divide these two, 56 pi divided by 7 pi, you're going to get that this is equal to approximately 25.13. So that's equal to K cubed. All right, so again, to solve for K here, we need to get rid of this 3, and we're going to do that by taking the cube root of both sides, right? So then on this side, these cancel out, and we're left with K is equal to the cube root of 25.13, which is equal to approximately 2.93. Okay, so this is our scale factor. Okay, now what do you do with the scale factor again? You set this scale factor equal to another fraction. And in that fraction, instead of comparing the volumes, you're going to compare two dimensions. Okay, so for instance, here, the two dimensions we can compare are the heights, right? So this height right here, that's unknown, and this shorter height, that's given as 5 feet. So we can plug those two in. And which one goes on the top and which one goes on the bottom? Well, first, on this side, we have B on top and A on the bottom. So we're going to do the same thing, right? So we're going to put B on top, which is just H. And then we're going to put A on the bottom. So cylinder A is on the bottom, so 5 feet, right, on the bottom. All right, great. So now that our second little formula is set up, let's plug in what we know. So for K, again, that's equal to 2.93, and that's going to be equal to H over 5, right? H over 5. So to solve for H, we can get rid of this 5 by multiplying both sides by 5. On this side, they cancel out. So we're left with H is equal to 5 times 2.93, which is equal to 14.65. And our units are feet, right? So the height of this cylinder B is 14.65 feet. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.